The load line has an eye at the end. The eye is used with rigging hardware to attach the load line to the load. This winch is designed so that the load line comes off the drum horizontally. Rigging hardware redirects the load line up to a simple block and tackle mounted overhead. Before operating the winch, the rigger must securely mount the winch in place to prevent it from sliding along the floor as the load is pulled. Sometimes a winch can be bolted directly to the floor, but in this example, the rigger will secure the winch to the foundation of a steel beam. First, he attaches a sling to the winch and wraps the sling around the beam. Next, he places wooden blocks between the sling and the sharp corners of the foundation to prevent the sling from being damaged. These blocks are called wear pads or softeners. Once the winch is securely in place and the rigger has connected the air supply to the pneumatic motor, he tests the controls on the winch. The test includes checking the winch's operation in both directions as well as checking the brake. When the rigger is sure that the winch is functioning properly, he attaches the load line to the load. After receiving the signal to begin the lift, the rigger sets the motor control to the lift position and releases the brake. As the motor turns, it rotates the drum and reels in the load line, lifting the load. When the load reaches the correct height and the stop signal is given, the rigger applies the brake and stops the motor. To lower the load, the rigger sets the motor control in the lower position and releases the brake. He lowers the load until he receives the stop signal. Then he applies the brake and sets the motor control in the stop position. Once the load is completely lowered, the rigger disconnects the load line from the load. Then he reels the load line back onto the winch drum. Finally, he disconnects the winch's air supply and removes the sling that secures the winch to the steel beam. In this topic, we examined some common lifting and supporting equipment. We saw how hoists and come-alongs can be used to lift a load from above, and we saw how jacks can be used to lift and support a load from below. We also took a look at winches, and we saw how they can be used to lift a load. Let's pause now so you can try some practice questions on this material. In this part, we'll take a look at slings, and we'll see how they can be used in rigging a load. We'll also see how sling angles affect the lifting capacity of a sling. A sling is a device that's used to attach a load to a lifting device, such as a hoist or crane. Slings are commonly made of wire rope, chain, or synthetic fiber. An important part of using any sling is choosing the correct sling for the job. One factor that affects how much weight a sling can hold is the lifting capacity of the sling. An important point to keep in mind is that the rated lifting capacity of a sling is the amount of weight that can be lifted by a new sling that's used in an approved hitch pattern. The rated lifting capacity also depends on the angle at which the sling is rigged. Information about the rated lifting capacity of a sling can usually be found on a tag attached to the sling or in the manufacturer's manual. For example, this sling is rated to hold 5,300 pounds when it's used in a vertical hitch. But when the sling is used in a choker hitch, the rated capacity drops to 4,200 pounds. When the sling is used in a basket hitch, the rated capacity actually increases to 10,600 pounds. Let's take a closer look at how hitch patterns affect the rated capacity of a sling. This is an example of a sling rigged in a single-leg vertical hitch. A vertical hitch pattern is used when the sling will lift a load straight up. In this type of hitch, the sling carries the full weight of the load. In our example, the sling is able to carry loads up to 5,300 pounds. When the sling is combined with other slings in a bridle hitch, each sling carries an equal portion of the load. However, when this sling is used in a choker hitch, its rated capacity is only 4,200 pounds. The rated capacity is reduced when the sling is used in a choker hitch because of the tight bend created as the sling material passes back through the eye loop at one end of the sling. This sharp bend in the sling material causes the fibers or wires on the outside of the sling to stretch, while the fibers or wires on the inside are compressed. As a result, the sling material on the outside supports more of the weight of the load than the sling material on the inside. On the other hand, When a sling makes a large turn, as it does in this basket hitch, there is no increase in the strain on the sling material. In fact, this hitch pattern actually decreases the strain on the sling. When a basket hitch is used, the sling acts as if it were two separate legs supporting the load. That's why when this sling is used in a basket hitch, its rated capacity doubles to 10,600 pounds. Another key factor that affects the amount of weight a sling can safely support is the sling angle. In this example of a two-leg bridle hitch, the sling angle is the angle between the sling and the imaginary vertical line from the lifting point straight down to the load. As the sling angle is increased, the tension placed on the sling also increases, and the amount of weight that the sling can handle decreases. Let's look at some examples to see how sling angles affect the lifting capacity of a sling. In this illustration, the load to be lifted weighs 1,000 pounds. Two slings connect the load to a lifting beam. A device called a dynamometer is attached to each of the slings to measure the force that's placed on the sling. When the load is lifted with these vertical hitches, the sling angle is 0. The force on each sling is 500 pounds. But when the lifting beam is eliminated and the two slings are attached to a single lift point, the forces change with the sling angle. Here, the slings are connected so that each sling is at an angle of 30 degrees. The force created by the 30-degree sling angle is 577 pounds on each sling. If the sling angle is increased to 45 degrees, the force increases to 707 pounds. And if the sling angle increases to 60 degrees, the force goes all the way up to 1,000 pounds on each sling. With a 60-degree sling angle, the force placed on each sling is equivalent to the total weight of the load. If the sling angle increases to 80 degrees, the force on each sling jumps up to 2,880 pounds. A chart listing common sling angles and their effects on sling lifting capacity can be found in most sling manufacturers' literature. Typically, sling manufacturers recommend keeping the sling angle under 45 degrees. One way to change the sling angle is to change the length of the sling used in a lift. Let's look at an illustration to see how sling length affects sling angle. In this example, two slings are used to lift this load. Each of the slings is 7 feet long and at an angle of just about 60 degrees. If the sling length is increased to 8½ feet, the sling angle changes to approximately 45 degrees. If the slings are further lengthened to 12 feet, the angle is reduced to 30 degrees. One important aspect of safely lifting any load is ensuring that the load is balanced. When an unbalanced load is lifted, it could tilt or swing. If the load shifts suddenly, it could be dropped. To prevent this from happening, all loads should be lifted with the lifting device directly over the load's center of gravity. A load's center of gravity is the point at which its weight is concentrated. When an unbalanced load must be lifted with slings, the lengths of some of the slings must be adjusted so that the lifting device will be directly above the load's center of gravity. One device that can be used to balance a load is a turnbuckle. Turnbuckles can be used to make small adjustments in the lengths of sling legs. Lengthening the slings on one side of the load will shift the lift point over the load's center of gravity. A turnbuckle is a device that consists of a threaded body and two screw ends. The screw ends are threaded in opposite directions from one another. Because the two screw ends are threaded in opposite directions, the turnbuckle shortens when its body is turned in one direction and lengthens when its body is turned the opposite way. To keep a load balanced, it's important to select slings that are as close to the correct length as possible. Then use turnbuckles to make any small adjustments that may be necessary to balance the load. When you choose a turnbuckle, you must consider its lifting capacity. The capacity of a turnbuckle is determined by the diameter of the threads on its screw ends and by the types of screw ends that are used. The larger the diameter of the threads on the screw ends, the greater the lifting capacity of the turnbuckle. Turnbuckles are typically not marked to indicate their capacity. To determine a safe working load for a turnbuckle, you should check the manufacturer's manual. When a turnbuckle is used, one screw end is typically attached to the load hook on the lifting device, and the other screw end is attached to the sling. Then the body of the turnbuckle is rotated in the appropriate direction to either lengthen or shorten the length of the sling. Another leveling device is a load leveler. It's used when fairly large adjustments must be made in the lengths of the legs in a hitch pattern. This illustration represents a typical load leveler. The load leveler has a body with a support eye mounted on top, 2 chain legs, and 2 load hooks. A hex adjuster on the side of the load leveler's body connects to an internal worm and roller gear, which turns a chain sheave. The chain sheave is a sheave with pockets to pull the links in the chain legs through the body of the load leveler. When the load leveler is used, the support eye is hung from the load hook of a lifting device. Then each chain leg is hooked to a lifting point on the load. To adjust the leg length, the hex adjuster is turned with a wrench. The hex adjuster turns the worm and roller gear. The worm and roller gear turns the chain sheave. As the chain sheave turns, pockets in the sheave pull the links in the chain legs through the body. This causes one leg of the chain to lengthen while the other leg shortens. Lengthening one leg and shortening the other positions the lifting point directly over the load's center of gravity. In this topic, we saw why sling capacity must be considered when slings are chosen for a lifting job. We also saw how the rated capacity of a sling can change depending on the hitch pattern used for the lift and the angle at which the sling is rigged. We also looked at 2 leveling devices that can be used to help balance a load. Let's stop now so that you can try some practice questions on this material.